Hi, I'm Amrit Shilani, and through this short podcast, I will explain and present to you the basics of speakers. The importance of speakers in modern technology is paramount, as they are used in almost every electronic device and system today. Examples of everyday speakers are ordinary earphones, car speakers, hi-fi systems, laptop computers, mobile phones, radios, and the list goes on and on. A common misconception is that loudspeaker is just one device that produces different sound. In reality though, most speaker enclosures comprise of three such devices known as drivers that have different ranges of sound, as well as another electronic device that separates the inputted audio to different frequency bands and channels them to individual drivers that can handle them. This device is a crossover.
Drivers are also known as transducers. There are 5 different types of drivers for different frequency bands. From lowest to highest, these are subwoofers, woofers, mid-range drivers, tweeters, and super tweeters.
You may ask, why are woofers so much bigger than tweeters? I had the same question. The answer lies in frequency. Subwoofers and woofers are larger than tweeters because the notes that they produce are lower in frequency and have a longer wavelength. These notes require substantially more power to produce sound at an audible level. The components in subwoofers and woofers are larger than those in tweeters. The diaphragms of these drivers vibrate as slow as 40 times a second for a very low-pitched sound. Tweeters, on the other hand, are smaller, as they produce higher frequency notes and their diaphragms vibrate considerably more times in a second. This can be up to 26,000 times a second. Current passes through the voice coil, it becomes an electromagnet and causes the magnetic poles to be induced on either end of the solenoid. When the direction of the current changes, the poles switch, and this causes the surrounding magnet to exert an electromagnetic force of attraction or repulsion on the solenoid. In the case of a tweeter, the solenoid is attached directly to a diaphragm, and the cone causes them to vibrate inwards and outwards. In the case of a woofer, the solenoid is attached to a spider that vibrates with the solenoid and translates mechanical energy to the diaphragm. This movement pushes and pulls on air molecules, causing a snowballing effect on other air molecules. This creates sound waves.
Here I have a soft dome tweeter which I will try dismantling now.
Taking the lid off the soft dome tweeter, we can see right in here, this is the cone. Taking this bit off inside, we can see this is the larger magnet and this is the metallic core inside which the coil goes. Here we can see our voice coil. It's very small. It's connected to the diaphragm from the inside, as you can see, the cone. A movement of the voice coil would cause a movement of the diaphragm as well.